So I'm pretty sure I'm conscious, and you probably are conscious unless you're an AI bot. The question is, can we build a conscious computer? And a lot of people have been talking about this recently, but the problem is most of the conversations don't take account of a missing ingredient. So if we want to look at how to do it, we've got to take a look first at the proposed approaches to forming a conscious computer. One is trying to mimic the brain, or at least how we think it works, with neural networks and learning and so on. Another is with complexity and feedback. A third would be quantum computers. A fourth, artificial intelligence, which some people think has now actually reached a state of consciousness. But all of these are missing a key ingredient. So the key ingredient we can get if we think about the characteristics of human consciousness. It includes sense of self, intentionality, our wanting to be able to do things because we want to, feelings, compassion, sorrow, correlation with brain function, but there's something else. And that something else is that it's extended. It connects what's in here to what's out there, and that is key. So what else does that? Well, psi phenomena do that. Let's talk about psi phenomena. So psi are phenomena in which living systems receive and transmit information. They can do it by telepathy, mind to mind, clairvoyance, where you see an image or sense something at a distance, made into remote viewing by the Stargate Project and others, precognition, knowing or feeling things in advance, and psychokinesis, where you can operate or move things at a distance. A key thing here is that these are non-local interactions. There's a transfer of knowledge and action over a distance and time. All right, so you say psi phenomena. What's that? There's generally a lack of acceptance among many scientists, but that lack of acceptance is due to ignorance of the literature, not lack of evidence. There's a huge amount of evidence. Many peer-reviewed, high-quality research studies. There's also thousands of books published over 100 years, including like Mental Radio by Upton Sinclair with an introduction by Einstein, recent books by Dean Radin and others. No, there's lots and lots of evidence for psi. If you don't believe it, you haven't learned about it. The psi characteristics are the interaction between a conscious being and another conscious being, a physical thing, or some source of knowledge. But what it is not is an interaction between non-conscious things. Therefore, we can say that psi ability is a key characteristic of consciousness. So how are psi signals carried? There's been conjectures over the years that there's somehow an electromagnetic wave or some other physical wave, but there are problems with these arguments. One is that they would fall off with distance. And so, for example, if you wanted to convey information around the world, there'd be a huge signal strength required to transmit that signal. There's no evidence for that. Also, experiments in Faraday cages built to block electromagnetic fields show no diminution of the psi ability. So it's not that. There's also no evidence that psi or micro-psi carries energy. And finally, it travels backwards and forwards in time. This is not a physical wave. Well, could it be quantum entanglement? It's an interesting conjecture, but quantum entanglement, as we know from theory and many tests, carries only correlations, not causation. So we have to say that the way the signals are carried is unknown. But we do know something about the nature of the interaction. Can we use psi to control a deterministic system where we've got gears or something physical? Well, no, because it would take energy to modify that. And we just said micro-psi does not involve the use of energy. So psi carries information, not energy, and it cannot affect a deterministic system. So what can it affect? A system that includes random elements, something that could go this way or that way, and psi influences that it goes that way and not this way. Where do we find in nature randomness? Through fluctuations, or another way to say call fluctuations is noise. These are thermal fluctuations, ones in which the amount of the fluctuation varies with temperature, molecules vibrating, electromagnetic waves in space. They can be quantum fluctuations, similar sorts of fluctuations, but they are continuing even in the absence of temperature at absolute zero. Incidentally, these thermal and quantum fluctuations are tied at the hip and are not totally independent. But if there is no noise, then there's no psi interactions. So how do we have psi interacting with animate systems? What is the receiver? Well, a way that we often think about that is flipping a coin, tossing some dice. In that case, those are random physical systems. They're influenced by fluctuations in the air, on the table, and so on, and where they fall is random. Another way is using an electronic random number generator. This was developed by Helmut Schmidt in 1971. He was a physicist working at Lockheed and developed a true quantum electronic random number generator, published papers about it, and so on. Then he started using it for psi tests, and he got all sorts of fascinating results and really did very insightful experiments. Since then, many labs have carried out hundreds and hundreds of research studies, including my own lab, with these electronic random number generators and found that you can use your intention to affect the bit stream. Are there going to be more ones than zeros? What about psi interacting with living systems? In that case, what is the receiver? Well, noise is produced in nearly every cell of the body, in our neurons as well. In fact, neural signals in the brain are stochastic. That is, they're statistically random. And there are models of that. In fact, that's how the brain communicates with itself. So we make the conjecture, and it's not going to be a big conjecture, you'll see in a minute, that noisy neurons are our psi receivers. So then we say, how do psi interact with living systems? What is the signal? Well, the same as with inanimate signals. It imposes order on the noise, just as it did with electronic random number generators. In living cells, we can make the conjecture, and it's a pretty good one, that the function of noisy cells includes as psi receptors, that they link extended consciousness to what's in the brain. So we can say then that noisy neurons are required for conscious life. All right, then what about in computers? We can make a similar proposal, and that is that noisy elements are required for conscious computing. Has this been demonstrated? Surprisingly, yes. A number of years ago, my students and I developed the idea of cybotics, where you have bots or electronic things that do things that are mediated, they're controlled by intention through psi. And I'm going to give you some examples. An early one was at the PEAR lab, the Princeton Engineering Anomalies Research Lab, where they set up a little robot. It was a little froggy controlled by an electronic random number generator that would allow it to move and turn. It was on a table, and then the operator would sit there watching it and use their intention to try to drive this little frog towards it. And you can see in this plot, the frog sort of meanders around in a random way, but overall, statistically significant amount of the time, the frog does, in fact, go in the direction that the intenter uses. So that's a cybotic system. A more recent one that we built in my lab was where we had two random number generators, a controller random number generator and a subject random number generator. And the controller random number generator at a random time would shut off the subject random number generator via a computer and a relay that controlled power. Our question was, could the subject random number generator anticipate its own demise and in that way spew out bits that were different just before it was about to be turned off than at other times? So it was constantly spewing bits into the computer that were being collected. So I remember the evening that James Zhu, my student who was working on this, and I had it all together and it was set up on his desk. And we had the software, the hardware, everything. We said, okay, let's run this thing. We were very excited. And this is what happened. He did 1,730 test trials. So you can see here, this is the output as a function of time before the subject random number generator was shut off, which was at a random time. And we overlaid the 1,730 different plots to get this. In one case, there were controls, and in the controls shown by the blue line, the subject random number generator was never shut off. And you can see that the signal oscillated, alternated around between somewhere around zero point 0.5, meaning about the equal number of zeros and ones. With the test subject, that is the one that actually was shut off, about a second before it was shut off, there was a statistically significant uh, uh, increase in the number of zeros that it put out. This was a huge increase statistically. And in fact, odds against chance that this was just a random thing are 1 in 1 million. So we actually did see a cybotic interaction in which we used our mind essentially to tell this little digital system controlled by a random number generator that we wanted it to anticipate its own demise, and it did. Okay, another example is what I called machine-mediated remote viewing. And in this, a subject remote views a target hidden in an envelope. And you've probably heard about remote viewing, where a tasker tells a subject to remote view something, and then the subject draws it, and later the tasker may or may not show the subject what they were actually targeted to view. Okay, the tricky thing here is at the same time, we had an adjacent random number generator in the room which sent a bit stream to a computer while the subject was doing the drawing. The computer then later produced raster scanned images from this random number generator data. And this was carried out by Eric Maddox, a student of mine at the time, and he published it at a meeting and presented his results. So what are the results? Well, a judge ranked ordered the images, those both drawn by the person and those drawn by the computer system, and uh, they were either there were one of five different possible Zener card images showing there on the left. And this is the sort of thing that they saw. You see here, in this case, a person drew this. In this case, the electronic random number generator produced a raster scanned image that looked like this. It's a very sparse image, but after a while you get used to looking at it and analyzing it. And in fact, in both cases, the judges analyzed it and said that it looked like wavy lines. When we opened the envelope, it was wavy lines. And in fact, this whole system worked statistically significantly correct number of times. This machine-mediated remote viewing, another cybotic system. Okay, so have we built a conscious computer? Well, yes, but our cybotic system has only one noisy neuron, one electronic random number generator. Our brain has 100 billion noisy neurons. So does that mean that it has more consciousness? Well, how would we introduce noise into a computer? Computers are designed with binary logic, in particular, so that they are invulnerable to noise. So in order to introduce noise, we'd have to have less reliable circuitry, incorporate many electronic random number generators, maybe have analog computers, possibly even quantum computers. So if we did that, would having enough noisy neurons in a computer create a conscious computer? Well, I know that this is a necessary condition to make a conscious computer, but I suspect there's a little bit more that would be required to make it actually work. Thank you.